All right, welcome. This is lesson 1.1, which is going to be about graphs of functions. Hopefully this will be a short video today because I'm getting this out to you a little bit late. And there's really not a whole ton to talk about with graphs of functions. This is going to be the basics about using graphs for domain and range and evaluating the function and so forth. So yeah, let's dive in. Okay, first, what is a graph? That's what we're going to be talking about today. So the definition for what a graph is it's going to be all the points where your first number is your input, x, and your second number is your other coordinate is the output, f of x. So it's all the points that look like that, x, f of x, as x varies over the domain of the function. So whatever your domain is, that's going to be all of the x coordinates, and then you're going to plot the point x, and then the function evaluated at x, you're going to plot those points to get the graph. So it's all of those points. That's what a graph is. And what a graph is good for, well, it's a visualization of the function. It lets you see some things about the function, like if the function has a maximum or a minimum, what the domain and range is from the function, what the values are, et cetera, et cetera. So it tells you a lot of information about a function. It makes it very visual, which is good for those of you that are visual learners. When we graph things on the coordinate plane, we always use the horizontal axis. So the left-right axis is going to be for our inputs, the x values, which is the first coordinate. So I just want to highlight this. Our horizontal axis is going to go with our x's. And we're always going to use the vertical axis for the y's, or the f of x's. So the vertical axis is going to go with our outputs. Okay, so it makes things it's good to standardize things in a certain way. That's how we're used to doing it. Your x's are your horizontal values, and your y's or your f of x's are your vertical values. Okay. All right, so here's an example of what a graph might look like. That's part of the graph f of x equals absolute value of x. Okay, so you can kind of use the graph. We'll tell you how you can use the graph to read values and determine domain and range in a moment. In case you remember, just in case you're curious, the domain for this graph is all real numbers, and the range is from 0 to infinity. Okay, so maybe from that you can determine domain. That's enough to know how to get domain and range from a graph. Okay, but in case I wasn't, I'm going to tell you how to get domain from a graph. So you can use the graph to determine the domain. Basically, what you want to do is scan the graph from left to right. So you're going to walk across the graph and see if there is a graph there. And if there is no graph, so if it doesn't exist, as you're scanning, then those numbers are not included in the domain. So you're not going to have those values for your those numbers for your inputs. Okay. So here's an example. That's the graph of the square root of x minus 1, and I just got this from Desmos. So you can use lots of graphing tools or your graphing calculator to get graphs. And if you scan this from left to right, so let's do that together, you're going to see, we don't have values, so there's nothing. So there's nothing over here. It's nothing, nothing, nothing. And then we start right there, and that's the value, or that's the x input of 1. So we don't start to get graph until we get to 1, and then we get graph after that. So we can determine that the domain is 1 to infinity from that graph. There's nothing over to the left of 1, so it's not in our domain. Okay. All right, so you can also read the range from a graph, whereas with the domain you are scanning from left to right, going across that way. For the range, you're going to scan from bottom to top. Okay, so from the bottom going up. and bottom being negative infinity and top being positive infinity. And similarly, if no graph is there, then those values are not going to be included in the range. So let's take a look at a graph. So this is, oops, drop my pen. This is the graph of f of x equals negative x squared plus 3. And so let's try this. Let's try to scan this from, bottom to top. So we do have graph. So there's graph as we go up. As we go up, we get graph, and then we stop right at 3. And then there's no graph up here above f of x equals 3. So 3 is at the top of our graph. And so from that, we can determine our range goes from negative infinity, so all the way down at negative infinity, because these keep going, up to 3, and then we stop there. And we get 3 as well from that. So there's no graph above 3, so that's why this is our range. Okay. All right. And so you can also use the graph to determine values. Values meaning answers. So if you want to get the value from a graph, you want to draw a vertical line at whatever input you're interested in evaluating. So, you know, for example, if x is equal to 2 and you want to find what's f of 2. So let's do that in a moment. But then you read the y value where the line intersects the graph. So let's take a look at an example. So here's a weird one. This is the graph. The red curve is the graph of x to the 1.4. Yeah, that's right. You can have decimal exponents. It's a little bit weird, but they're perfectly valid. So here's x to the 1.4. And if you look up what is f of 3, so I'm interested in finding what's f of 3. And that's going to equal 3 to the 1.4. And you know, that's a weird number, and you could plug it into your calculator and evaluate it. But we can read it from the graph by drawing this vertical line right here at x equals 3, and then seeing where it intersects. So if we check out where it intersects, it's right here, up here at this y value. And we can kind of draw, if we want, we can draw a horizontal line across to see what the y value is going to be at that intersection point. And it looks like it's about 4.7, 4.6, something like that. And so that's how you can estimate the function's value from a graph. You draw that vertical line, see where it intersects, and then estimate the value. Okay. And the actual value, if you were to plug that into your calculator, is about 4.65, and there's more stuff there. So it's a pretty good estimate. All right. And then one thing to be mindful of is that not all graphs that you're going to draw, or not all curves on a coordinate plane are going to be, that's some math on the board. Not all graphs will be functions, okay? And so there's this thing called the vertical line test. And this is an important test to determine if a curve is a function or not. Later on, we're going to talk about the horizontal line test, which is different from the vertical line test, but tells you some other information about a function. The vertical line test tells you if a graph is a function. So it's a graph is a function if every vertical line intersects the graph at most once. So some vertical lines won't hit it at all, and some will hit it once, but none of them can hit it more than once. Otherwise, it's not a function. Okay, so let's look at an example. So this is the graph of a squished circle, also called an ellipse. You can write that word over here in case you're curious. So this is an ellipse or a squished circle. One thing to note: the Earth is a squished ellipsoid, so it's not actually a perfect sphere rotating in space. It's a little flatter, so and squished down a little bit, so that's interesting. You might think of this as like an egg shape or something like that. But anyway, so this ellipse if you were to test a vertical line, so it's not a function because it fails this vertical line test. For example, if you draw a vertical line here when x equals 0, you'll see it hits twice, right? We hit here and we hit again there. And so we intersect the graph twice, once at 0, 1, the other at 0, -1. That's not a function because it fails this vertical line test. What we're saying here is that, you know, this is what the function would be evaluating to, right? It would be f of 0. We plug 0 in and we're like, well, the answer is 1 or -1. So there's multiple answers for it. And so this isn't a function, right? Because we can't have two answers. We need just one answer for it to be a function. Let's look at one more example with the vertical line test in play. Now I want you to look at this graph and tell me, is this a function or is it not a function? And you can kind of like try some vertical lines on your screen and see if those are going to hit more than once. So let's go ahead and pause it and see if you can determine, is this a function, is this not a function? Okay, so hopefully you tried drawing a couple of lines. So if we try drawing some vertical lines, that hits it once, that hits it once, okay, that hits it once, okay, that hits it once. All right, looks like no matter what line I draw, vertical line, I'm only hitting the curve once, so that means it is a function. So this curve is a function. It's a weird one. This is actually equal to, in case you're curious how I got this function, this is sine of x 3 times the sine of x plus x. That's a weird one. You can graph it in Desmos to see that you get something that looks like this. But anyway, it's a function. You plug in one number, you get one number out. This function up here is not important. I just wanted to let you know what it was in case you're curious. And you can see that every vertical line we draw intersects only once. And in fact, all the vertical lines will intersect only once. Okay, that's it. Short video for today. So hopefully if you've got any questions, you write those in Schoology or in the comments section here. And we're going to get some practice with reading graphs and determining if graphs are functions and so forth tomorrow. So, all right, I'll see you tomorrow.